All right, so it took a little longer for them to realize that positron emission was occurring because it's harder to detect. They knew about electrons at the time, and they could detect electrons for beta particles. The alpha particles were bigger and heavier, easier to detect because they were bigger and heavier. For positron emission, a positron 0 over plus 1 beta is produced. Now you heard me say in the beta decay video that occurs when there are too many neutrons in the nucleus. This occurs when there's too many protons, not enough neutrons. That ratio is out of whack the other way, the neutron to proton ratio. So in these cases, a 1 over 1 proton, again small p for proton, turns itself into 1 over 0 neutron plus the leftovers. Well, the mass is accounted for. We got plus 1 on the left and none on the right, so it's 0 over plus 1, and we still use a beta symbol for positrons. So we have 0 over minus 1 is a beta particle. 0 over plus 1 with the beta symbol is a positron. So this is our product. And the resulting nucleus is more stable because it's reapproaching that stability of neutron to proton ratio. So the equations for these, again, you're going to hear me say this a lot. They work all the same. Add the masses on the left, compared to the right, protons on the left, protons on the right. So one example of a material that undergoes positron emission is potassium-40. Potassium-40 undergoes positron emission. That means a positron is produced. So we put that one out as our product, and then we figure out what the daughter atom is. So in this one also, the mass number doesn't change. So the mass is 40. Now we got 19 minus a positive 1. That's just regular math, right? 19 minus 1, 18. Find the box 18 on the table, should be argon. So balancing these are much more straightforward like the alpha particle because there's not a negatively charged particle to deal with. So we're a couple more of these. Boron 8. Boron is atomic number 5. Undergoes beta emission to produce. We got to figure out what the rest is. Mass didn't change. 5 minus 1 is 4. So we get beryllium out of that. Beryllium 8. Work another one. Carbon 11. Carbon 11 is 11 over 6 carbon. Undergoing positron emission. 0 over plus 1 beta. Mass doesn't change, so the daughter atom has a mass of 11. 6 minus 1 is 5. So we get boron 11 out of that. If any of you have either yourselves undergone a positron emission scan or had a family member, friend, whatever, do a PET scan, PET, positron emission tomography. During that process, they will inject you with a material that undergoes positron emission. And the one that's most frequently used is carbon 11. They will inject you with carbon 11. As it flows through your bloodstream and into different areas of your body, it undergoes this decay. And this decay results in something that they can interpret. Now, we don't hear a lot about positrons building up in the environment. All of these positron emissions, all those positrons that get emitted, would build up if they didn't react with something. And it just so happens that 0 over plus 1 beta, when positrons collide with an electron, now let's balance this as a nuclear reaction. No mass on the left means no mass on the right. 1 minus 1 is 0. What do we have before that was no mass, no charge? Gamma. And we actually get 2 gamma rays out of that. Positrons are antimatter for electrons. When a positron and electron meet and they collide, they disintegrate. And that mass is converted into energy, equals mc squared. The mass is converted into energy, and we get positrons converting into gamma rays. Now, the reason this works for PET scans is that these two gamma rays are shot out of their position at exactly 180 degrees. So when they inject you with a positron emitter and put you in a PET scan instrument, you get slid into a tube, and that tube all the way around you is nothing but a bunch of detectors. And when a detector flashes here, that a positron must have emitted a gamma ray, and here, 180 degrees apart from each other, they can calculate where that was in your body by the difference in time for it reaching the detector. If this one hit first, the emitter was closer to that side than over here. So they can calculate where it is in your body, and they can put together a 3D picture of where all of the decays occurred in your body, and they know how your circulatory system is working, or how something is not working if it's not working. So that's kind of how PET scans work on a really rough back of the envelope type diagram. Okay? But the detector detects the difference in timing of those gamma particles hitting their two respective detectors. Come back, we got one more type, we got electron capture to deal with, and then we'll move on.